Hello students and good afternoon. So now I am doing class for class 12. The topic is the same topic that we were doing in the last online class, that is integration by the method of substitution. So same exercise 6A, page number 351, 4 marks section from the book Higher Mathematics for class 12 by Sailendra. So let's do this question now. Question number 33. So here question number 33 from the book is integral sine 2 to the power x divided by 2 to the power x plus 1 dx. So I will do this problem here. So that is your homework because these are similar type of questions. Okay. So let's do this problem now. So therefore I is equal to integration of 2 to the power x divided by 2 to the power x plus 1 dx. Okay. So how to do this problem? We can use the method of substitution here. So if you differentiate the denominator, let us check, are you getting the numerator or not? So what is the differentiation of 2 to the power x plus 1? For 2 to the power x is differentiation with respect to x is 2 to the power x log 2 base e. So log 2 base e is constant, but we are getting 2 to the power x, isn't it? That is 2 to the power x is in the numerator. That means you will get the value for 2 to the power x into dx. So we can use method of substitution in this case, and the differentiation of 1 is always 0. So let z is equal to 2 to the power x plus 1. Okay. So let us differentiate both the sides. Differentiating both the sides with respect to x. So therefore dz by dx is equal to, what is the differentiation of 2 to the power x with respect to x? It is 2 to the power x into log 2 base e, and for 1 it is always 0. So we have only 2 to the power x into log 2 base e. Okay. Now let us get the value for 2 to the power x dx in this case. Or now let us cross multiply 2 to the power x log 2 base e into dx. Okay. Now in this case we have to get the value for 2 to the power x into dx. So let us take this log 2 base e to the left hand side. So it will be dz divided by log 2 base e is equal to 2 to the power x dx. So I think you have understood it. Okay. So what is I now? So therefore I is equal to integration of, so what is 2 to the power x dx? So it is dz divided by log 2 base e. So it is dz divided by log 2 base e whole divided by, in the denominator there is 2 to the power x plus 1 which is equal to z. So here you can write z. Okay. So now which constant is there so that we can take it outside? Here 1 by log 2 base e is constant, you can take it outside. 1 by log 2 base e constant, integral sign, this is dz upon z. What is integral sign dz by z? You know integration of 1 by z dz is log z base e, right? So or I is equal to, this is 1 by log 2 base e into, what is this integration? Log within mod z base e plus c. So now you can put the value for z in this case. So what is the value for z in this case? It is 2 to the power x plus 1. We can put it here, or I is equal to, it is 1 upon, this is log 2 base e into log within mod, what is the value for z? It is 2 to the power x plus 1. It is 2 to the power x plus 1 plus c. So what is the base in this case? It is e. So this is the final answer. So similarly you can do that problem, that is integration of a to the power x divided by a to the power x plus 1 dx. So instead of 2 there is a. So you can do it at home. Okay. So this is the method. You can copy it. Now we'll do the next problem. So now let's do this question number 34. The question is integral of 10 to the power x minus 1 divided by 10 to the power x plus 1 dx. So how will you do it? Now in this case, first of all, you have to simplify this expression. Okay? So therefore, I is equal to integration of 10 to the power x minus 1 divided by 10 to the power x plus 1, and it is dx. Right? So in this case also, the method is whatever is there in the denominator, write it in the numerator. That is 10 to the power x plus 1 is in the denominator. Write down this expression in the numerator now. Or I is equal to integration of, it is 10 to the power x plus 1. Let us write it. Okay. So it is 10 to the power x, but instead of minus 1 there is plus 1. You have to make this plus 1 as minus 1. By writing, we can write here minus 2 whole divided by, this is 10 to the power x plus 1. Then what do we write here? Dx. Okay. So we can put it within second bracket. Is that clear? So or I is equal to integral sign within second bracket. Now you can separate the term. What is 10 to the power x plus 1 divided by 10 to the power x plus 1? This is 1, you know that. 1 minus, then this 2 divided by 10 to the power x plus 1, second bracket closed. Then you can write dx. So I think you have understood it. So we can separate the term now. Or I is equal to integral sign 1 into dx is dx, minus 2 is constant, integral sign, this is dx divided by 10 to the power x plus 1. So I think you have understood it. So we have separated the term out here. Now next, or I is equal to, what is integral sign dx? That is your x minus. So now how will you do this integration? So in case of exponential function, I told you about this one. If there is dx divided by e to the power mx plus 1, so how could you do that problem? So e to the power mx should be written in terms of 1 upon e to the power minus mx, isn't it? So in this case, we cannot use the method of substitution, because if you differentiate 10 to the power x plus 1, you will get 10 to the power x into log 10 by c, and there is no 10 to the power x in the numerator. So in this case, you can use the method of writing this 10 to the power x as 1 upon 10 to the power minus x, as we have done in exponential function. So in case of exponential function, that is if you have dx upon e to the power mx plus 1. So in this case, we can write, what was the method for this problem? We have done it in previous online classes. So integral sign, this is dx divided by, it is 1 upon e to the power minus mx plus 1. So likewise, you have to do this problem. That is your second integration can be done with the help of this method. Okay. So now I is equal to x minus, let us write it as I1. Okay. So let us write this second integration as I1. So let I1 is equal to, let us take it outside. It is 2 integral sign dx divided by, it is 10 to the power x plus 1. And for this integration, you can use this method here. Okay. Or I1 is equal to 2 integral sign dx divided by 1 upon 10 to the power minus x plus 1. Okay. So now in the next step, you can take the LCM here. Or I1 is equal to 2 integral sign dx divided by, what's the LCM in this case? 10 to the power minus x. So it is 1 plus 10 to the power minus x. Or this is I1 is equal to 2 integral of, this is 10 to the power minus x dx divided by 1 plus 10 to the power minus x. Now you can do the method of substitution, because if you differentiate 1 plus 10 to the power minus x, you may get 10 to the power minus x in the numerator, isn't it? So let us put z is equal to, let z is equal to 1 plus 10 to the power minus x. Let us do the method of substitution now in this case, okay? So we can differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So what do we get? That is dz by dx is equal to, differentiation of 1 with respect to x is 0. And what is the differentiation of 10 to the power minus x? It is 10 to the power minus x into log 10 base e into, again differentiate minus x with respect to x, which is minus 1. Okay? So now we can do cross multiplication here, or it is dz is equal to minus 10 to the power minus x log 10 base e minus 10 to the power minus log 10 base e dx. Okay, but in the numerator we have only 10 to the power minus x dx. So let us get the value for 10 to the power minus x dx from there. Okay, so you can take minus log 10 base e to the left hand side. So it will be minus dz divided by log 10 base e is equal to 10 to the power minus x dx. So we have got the value for 10 to the power minus x dx, which is equal to minus dz by log 10 base e. Let us put it out here. So therefore I1 is equal to 2 integration of, what is 10 to the power minus x dx? It is minus dz divided by log 10 base e minus dz divided by log 10 base e whole divided by 1. What is 1 plus 10 to the power minus x? It is z. It is z. Okay. So or I1 is equal to minus 2 by log 10 base e integral sign, it is dz upon z. So is that clear now? So what is integration of dz by z? It is log within mod z. Or I1 is equal to minus 2 by log 10 base e into log within mod z base e. Then what should you write here? Then you can write plus c. So I think you have understood it. So let us put the value for z now. Or I1 is equal to minus 2 by log 10 base e log within mod. What is the value for z in this case? What was the value for z in this case? It is 1 plus 10 to the power minus x. It is 1 plus 10 to the power minus x, mod sign closed. Then you can write plus c. So I think you have understood it. But this is not the answer. You have to put the value for I1 in I here. Since I is equal to x minus I1. So in this case, you have to substitute the value for I1. Okay. So now let us write here. So since I is equal to x minus I1 or I is equal to x, what is I1? Just now we have got the value for I1. I1 is minus sign is there, isn't it? So minus into minus is, this is plus. Now put the value for I1. It is 2 by log 10 base e, then log within mod 1 plus 10 to the power minus x plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 35. Integral sine root over tan x divided by cos to the power 4x dx. Okay, so therefore I is equal to integral sine root over tan x divided by cos to the power 4x dx. So how will you do this integration? So now this is the integration by the method of substitution. You know the method, isn't it? And you know that the differentiation of tan x is sec square x. So now we can convert this 1 by cos to the power 4x in terms of sec, isn't it? So or I is equal to integration of root over tan x into 1 by cos to the power 4x can be written as sec to the power 4x dx. Okay, as you know that the differentiation of tan x is sec square x. So it is the differentiation of tan x is only sec square x. That means we can break this term. Sec to the power 4x can be separated as sec square x into sec square x. Okay, so or I is equal to integral sine root over tan x into this can be written as sec square x into sec square x. And you know that the differentiation of tan x is only sec square x, only one sec square x. So let us put this within bracket, and this sec square x can be changed into tan x. So what is the formula for sec square x? You know that it is 1 plus tan square x, isn't it? So or I is equal to integral sine root over tan x, and within bracket we have here 1 plus tan square x into sec square x dx. I hope you have understood it. Okay, now you can do the method of substitution. So what is the relation between tan x and sec square x? Differentiation of only tan x is sec square x. So we can assume tan x as z. But since this is under square root, but it is in the numerator, don't assume this tan x as z square, because it is in the numerator. But if it happened to be in the denominator, then we could have assumed tan x as z square. यदि यो root over tan x है denominator मा भएको भए, we could have assumed tan x as z square. Okay, but since this square root is the numerator, no need of putting tan x as z square. Just put tan x is equal to z. Okay, so let z is equal to tan x. So differentiating both the sides with respect to x. Okay, so therefore dz by dx is equal to, for tan x it is sec square x. Now you may cross multiply. So what is dz is equal to, this is sec square x dx. That means we have got the value for this sec square x dx, which is dz. Now let us put the value for, let us put these values in I. So I is equal to integration sine, this is root over z, isn't it? So this is root over z within bracket 1 plus, what is tan square x? It is z square. It is 1 plus z square into, what is sec square x dx? It is dz. Now you can multiply them. Or I is equal to integration of within bracket, what is root over z? It is z to the power half into 1. That is, it is z to the power half plus, what is root over z into z square? Root over z means z to the power half into z square. If you multiply these two z, powers will be added. So this will be z to the power, this is z to the power half, this is half plus 2. Bracket close, then you can write dz. Okay, so or I is equal to integral sine, you can separate the term z to the power half dz. Let us separate this integral sine and dz also. Plus integral sine, this is z to the power, what is half plus 2? 2 to the 4 plus 1 is 5 by 2. Then you can write dz okay, or I is equal to, what is the integration of z to the power half? It is just like your integration of x to the power n. So it is z to the power half plus 1, 3 by 2 divided by half plus 1, 3 by 2. Plus this is z to the power 7 by 2 divided by 7 by 2 plus c. So I think I have understood it. So you can put the value for z now. Or I is equal to, this is 2 by 3. What is the value for z? It is tan x whole to the power 3 by 2 plus 7 by 2. It goes up in the numerator. That is, it becomes 2 by 7. And what is the value for z? That is tan x whole to the power 7 by 2. Then plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now let's do the next question, that is question number 36. Now we have to evaluate this integral, that is integral of within square root sin x whole to the power sin x divided by cos to the power 5x dx. Okay, so let us write here I is equal to integral of square root of sin x divided by cos to the power 5x dx. Okay, or I is equal to integral of within square root, you can separate the term here, that is sin x by cos x into, this is 1 by cos to the power 4x dx. Okay, so next, or I is equal to integral sin within square root. What is there? What is sin x by cos x? You know that this is tan x into, what is 1 by cos to the power 4x? This is your sec to the power 4x dx. So I think you have understood it. Okay. So now next you can simplify it further. What is square root of sec to the power 4x? Square root of tan x is root over tan x. And what is square root of sec to the power 4x? It is sec square x. So therefore I is equal to integration of, now this is root over tan x into, what is square root of sec to the power 4x? It is sec square x dx. So I think you have understood it. Okay. So now let us put z is equal to tan x, because differentiation of tan x is sec square x. So let z is equal to tan x. Now write down differentiating both the sides with respect to x. Differentiating both the sides with respect to x. So it is dz by dx is equal to sec square x. You can do cross multiplication. dz is equal to, this is sec square x dx. So what is I now? I is equal to integral sine root over, that is z. It is root over z. What is sec square x dx? That is your dz. So I think I have understood it now. So what is square root of z now? So I is equal to integration of, this is z to the power half dz. Now you can easily integrate them. Okay. So or I is equal to, what is integration of z to the power half? It is z to the power 3 by 2 divided by 3 by 2. That is z to the power n plus 1 divided by n plus 1. That is z to the power half plus 1 divided by half plus 1, which is z to the power 3 by 2 divided by 3 by 2. Then plus c. And in the next step, or what is I is equal to, now this is 3 by 2. It goes up in the numerator, becomes 2 by 3. So it is 2 by 3. And what is the value for z? The value for z out here is tan x. So it is tan x whole to the power 3 by 2. So it is tan x whole to the power 3 by 2, then plus c. So that is the final answer. So you can copy it. Now we are doing the next question. So now we'll do the next question, that is question number 37. So this is your homework. I'll give you the hints. So in this case, you have to integrate integral of within bracket 1 minus 1 upon x square bracket close e to the power x plus 1 upon x dx. So differentiation of which function is which one here? If you differentiate x with respect to x, you will get 1. And if you differentiate 1 by x with respect to x, I already told you about this differentiation. What is d by dx of 1 by x? It is minus 1 by x square. So in this case, you can assume, this is only the hint, let z is equal to x plus 1 upon x. So this is the hint. Okay. Now for number 38, how can you integrate it? It is given integral of e to the power x within bracket 1 plus x divided by cos square x e to the power x dx. So in this case, we can assume x e to the power x as z. So let z is equal to x e to the power x. You can use your UV rule or product rule. If you differentiate both the sides with respect to x, and if you use the product rule or the UV rule, you can get the numerator here. Okay, so you can do it at home. So you put x e to the power x as z. So let us do this question number 40 here. Okay, so now we have to integrate x square dx divided by a plus bx whole square. So how will you do it? So let I is equal to integral of, this is x square dx divided by a plus bx whole square. Okay, so how do you do it now? So we have to use the method of substitution in this case. Let us assume z is equal to a plus bx. Let z is equal to a plus bx. But while doing the method of substitution, you have to differentiate it with respect to x. So differentiating both the sides with respect to x. So what is dz by dx in this case? So dz by dx is equal to differentiation of a with respect to x is 0 because it is constant. And what is the differentiation of bx with respect to x? It is b. Is that clear? So now we can do cross multiplication, or dz is equal to b dx. Or next, you can take this b to the left hand side in order to get the value for dx. Let us take this b to the left hand side. So this is dz by b is equal to dx. So we have got the value for dx. So what is the value for dx here? It is dz by b. But there is x whole square is there. We can get the value for x from here in terms of z. So what is the value for x here? That is bx is equal to z minus a. And what is x is equal to? That is z minus a whole divided by b. So I think you have understood it. What is the value for bx here? It is z minus a. And what is the value for x here? That is z minus a whole divided by b. That is the value for x, right? So let us put these values in I. So I is equal to integral sign. What is x whole square? What is the value for x? It is z minus a whole divided by b. This is z minus a whole divided by b. That is your whole square. That is the value for x. And what's about this dx? Dx means dz by b. Dx means dz by b whole divided by, what is a plus bx here? This is z whole square. So this is z whole square. So I think you have understood it. So let us simplify it further. Which is constant here that you can take outside? Which is constant here that you can take outside? That is 1 upon b whole square. 1 by b square into 1 by b, that is 1 by b cube integration of, what is z minus a whole square? You can use the formula of a minus b whole square, which is a square minus 2ab plus b whole square whole divided by, this is z square. Then you can write dz. So I hope you have understood it. That is z square minus 2az plus a square whole divided by z square. Okay. Or I is equal to 1 upon b cube integration of within bracket, you can separate the term. What is z square by z square? 1 minus, next, what is 2za by z square? It is 2a by z plus a square divided by z square, bracket closed. Then you can write dz. Okay. So now, sorry for the disturbance. So now we are doing this problem. So we can separate the term here, or I is equal to 1 upon b cube integral sine dz. Okay. Next, minus 2a upon b cube integral sine 1 by z dz. So in this case, you cannot take this z to the numerator. If you take it to the numerator, it becomes z to the power minus 1, and x to the power n cannot be minus 1. If n is equal to minus 1, you cannot integrate it directly. So you have to write 1 by z dz. Okay. Plus, this is a square by b cube. This is a square by b cube, integration of 1 by z square dz. So I think you have understood it. So now let us integrate them. Or I is equal to, this is 1 by b cube. What is integral sine dz? That is your z. Minus 2a by b cube. What is integration of 1 by z? dz, it is log within mod z base e, plus, that is plus, it is a square by b cube, a square by b cube integral sine. But in this case, you can take this z square to the numerator. So it becomes z to the power minus 2 dz. So here x to the power n form is there. So n can be negative 2. So that we can use the formula of x to the power n plus 1 divided by n plus 1. So or I is equal to 1 upon b cube. What is the value for z in this case? It is a plus bx, bracket close, minus 2a by b cube, log within mod, what is z? It is a plus bx, the base is e, plus a square by b cube into, what is integration of z to the power minus 2? It is z to the power n plus 1 divided by n plus 1. If you write n plus 1 here, it will be minus 2 plus 1, isn't it? This is minus 2 plus 1 divided by minus 2 plus 1. Then what do you write here? C. Okay. So you can multiply it. Or I is equal to, how much is it now? This is a by b cube plus this is x by b square, isn't it? That is bx by b cube is, you can cancel this b cube by b, so it is x by b square, minus 2a by b cube. This is log within mod a plus bx, the base is e, and now here it is plus a square by b cube into, this is z to the power minus 1 divided by minus 1 plus c. So next, so or, now in this case, this a by b cube is free from x, so it is a constant quantity. So no need of writing this constant quantity here, as we have written c as a constant term here. If c is written as a constant term here, you don't have to write this a by b cube. So it is sufficient to write c only. Okay, so you don't have to write a by b cube because it is a constant term. So next, this is x by b square minus 2a by b cube. This is log within mod a plus bx, the base is e, plus and minus is minus a square divided by b cube. Z to the power minus 1 can be taken to the denominator to make it z to the power 1. Then what do we write? Plus c. So or I is equal to x upon b square minus then this is 2a by b cube log within mod a plus bx, mod sign close, the base is e, minus a square divided by b cube within bracket z is a plus bx, then you can write plus c. So this is the final answer. So the answer for this integration is this one. Okay, so I think you have understood it, so you can copy it. So now this much is for today. त आज हामीले जति पनि प्रब्लम्सहरु गर्यौं यो सबै नै इम्पोर्टेन्ट हो। यो सबै नै तिमीले घरमा रिभिजन गर्नु अनि होमवर्क दिएको पनि तिमीले घरमा गर्नै पर्छ, बुझ्यौ? त जति पनि प्रब्लम्सहरु गरेका छौ सबै रिभिजन गर्नु। So in the next online class we will do more problems on this integration by the method of substitution. So this much is for today.